Hello, chat. Hi. Before we get started, I have a few things I want to talk about. First of all, let me bring up the VM. I don't know why I'm opening up this in the VM, but it's fine, whatever. Alright, so... Okay. The MV is out for what I've been working on. Let's see. There. Go watch. I spent a lot of time on this project. Rise Up cover. Yeah, this was released just a few minutes ago. By a few minutes ago, I mean 52 minutes ago. Yeah, go watch. I worked a lot of time on this, and got a music video made as well. I'll be putting that... Oh, I just realized you can't hear it. Oops. It's in chat. I'm not gonna play the entire thing, but... yeah. Probably gonna play Geigen now, a minute of this. Okay, yeah, that's the cover. Go watch the entire thing on YouTube. A few things I want to talk about. First of all, why is this... Can I click on this? Oh, I can't, okay. Right, so first of all, I want to thank a few people that were involved in this project. So, first of all, this person drew a lot of good Teto stuff. Okay, I can't really check the media tab, but yeah, only has like 1,000 followers or something. First time I saw their work was, yeah, this one. I thought it looked really nice, so I commented for the Teto used in this music video. Now second, music video. Right, so... do I have to log in? Okay, so... it's easier to just open their, VGen instead. But yeah, Mika, I assume that's how I'm supposed to pronounce their name. But yeah, Mika, they worked on my... I think they worked on my Twitch overlay, I think. Let me double check. Yeah, Mika. Mika worked on my Twitch overlay, and that includes the stuff from the usual gaming ones and just chatting ones. I calmed them for the music video as well, and she did a lot. Like originally when we were discussing this, I showed her the original music video. She was like, "Yeah, it seems a little complex. We might have to tone this down a little bit." I was like, "Sure, whatever." So I was expecting like a very simple MV, but this actually exceeded my expectations. This was very... If you never watched or listened to the original, here. It's like decently close. Not including the ads. Yeah, I get it. Wow, battery. Woo. But yeah, look at the original video, the original music video. They actually got most of it decently translated over. Like, yeah, not the entire thing, but like it's close enough that I think it's really good. So yeah, go follow these two people, and if you've never listened to original, go listen to original as well. I love this. I love the song from Luna. This song was used for Hatane Miku Fitness Boxing. It's a theme song for it. So yeah, that's how I came across it. Okay, yeah. Go listen to music. Go watch MV. Comment, like, subscribe, etc., etc. I guess I don't usually do self promo. I don't know. Okay. Second thing, I don't know if you guys can notice. So first of all, the game capture lagging issue we were having last stream, that's been fixed, I think. So it turns out I accidentally enabled the SLI capture mode, and that's like really slow. That aside, also I've spent like 30 minutes figuring out how to improve the latency between the model and the voice. I think it's mostly synced up now. Before I had set to like 70 milliseconds of delay, but turns out that was a little too much. Setting it to like 13 milliseconds or something made the voice sync with the model a lot more. So I hope it looks a little bit more responsive now for my like mouth movement. Okay, is that all I want to talk about? I think. Do I have Git installed? Because we're gonna need it for today's story. Why is it so small? Here we go. I wish I could install Windows Terminal on here, but yeah, I'm using an older version of Windows 10. I tried all the versions of Windows Terminal, none of them work on here. That's unfortunate. Anyways, let's get to today's topic. So, this campaign was from a few days ago. I managed to actually catch it while it was also happening. If you guys follow me on Twitter, you might have seen me mention it, along with the C2s and ILCs involved. But if you don't know what I'm talking about, let's start from the beginning. Alright, so this has been an ongoing operation for a little while. I'm sure this is documented somewhere. Okay, I can't find it right now. Actually, give me a second. Let me try to find it. Because I'm pretty sure there's an article on it. Right, this should be it. If it loads. I hope it loads. Maybe I can't even load routers. There we go. Okay, that's not a very helpful one. Wow, the internet is pretty slow right now. Oh, I know why. Stop it, Windows Update. Get out of here. Hello? There we go. This might be a little bit better to read. No. Oh, wait. No, yeah, that one. Okay, so this has been documented for a little while. Can I Google Translate this? Right. Okay, so let's talk about what we saw yesterday. So, or the day before. I don't know. I don't remember. So, on I think it was Malware Hunters, whatever. Let me bring that up actually. This was brought to my attention because I follow Malware Hunters' Twitter account. They mentioned that they saw this repository. I don't know how they came across it, because normally Bitbucket isn't the easiest to search code on. So like, unlike GitHub, you can't just like do a code search on Bitbucket. I think it's only the search is limited to your repositories only. So I don't know how they came across it. Anyways, so they came across this repository, and once again, I don't know how. Okay, there are two repositories. This is one they saw, and it looks fine from the beginning, but we'll get to. Tell you what, we'll talk about the code itself first, and then we'll talk about attribution at the end. Okay, so let's start from the beginning. Okay, so Malware Hunter first saw the repository back when, like in 2 days ago, I guess, 11 p.m. I think that's Pacific time in the PM. Anyways, so they saw this, and at first glance, you might just think, oh, this is just another repository that looks fairly mundane. And if we look at the other repository that this user has, which was not mentioned in the tweet, I had to like log into Bitbucket and then go back, and then you can view the user's repository. And this one's called Social Book. Apparently, it's for private encrypted chat messages, and it's fully open source or something. And you can see that both of these projects are pretending to be, very innocent open source projects. So if I open these in VS Codium, we can actually look around. You'll see that the README doesn't really say anything. It just tells you to do npm install, etc., etc. And there's also a tsconfig. It's for TypeScript. It all looks fine. If we look around in source, you'll see that it's for, like, if we look at the about, you'll see that this is, I assume this is like a very basic template for a website for transactions and whatnot. If you look at the even includes a basic login page, a basic checkout page, etc., etc. Like, it all looks fairly normal, right? The thing about this campaign, though, is that it looks fine on the surface, and usually the way this works is they would usually put these decoys on. I don't know if they contact the individual specifically or if they put the decoys on LinkedIn. But basically, they do their recruits on LinkedIn and every other various recruitment platforms. And they'll send you a demo project. And it's as if it's part of the interview. And they'll ask you to, test and run the code. And unbeknownst to most people that fall victim for this is that usually somewhere in the JavaScript chain is laced with malware. And since they expect you to use npm or Node.js, your code will be executed as as JavaScript locally, and that could lead to a bunch of things. Now, if we look at in this specific project, we're looking at tailwind.config.js. It looks fairly normal, right? If you zoom out, it looks fine. Look, just be like, hey, this seems like the usual Tailwind config stuff. What's wrong about this? So, as part of this operation, what they would usually do is they would put the JavaScript way behind a certain line. So it all looks fine until you start scrolling to the right. Alright, you'll see there's a bunch of white space. Looks like nothing, right? Keep scrolling, and you'll see that there's JavaScript, like right behind the first line. And you can't usually tell this on the various Git hosting websites because word wrapping is not enabled by default in most of the editors. So that includes GitHub, Bitbucket. I don't know what else. I think Git might also not follow word wrapping. So like you have to go into the editor. I'm not even sure if Bitbucket supports word wrapping in their editor, but I know GitHub does. But like you have to go to GitHub and go to the top right and click, and then click on drop down and select word wrapping. Then you'll see that this is laced with malicious JavaScript. And yeah, it's very cheeky because on first glance you're really not gonna notice because most people don't really have word wrapping installed. Most people don't have word wrapping enabled anyways. And second, usually people that come across these open source projects, they'll usually just run it because they trust, open source equals safe, right? That is not the case, of course. Just because you can view the source doesn't mean that it is safe. Doesn't mean you should just blindly run it. Now, in today's stream, we're going to talk about this specific JavaScript code and what it actually does. Now, a few things you can usually do when it comes to this is you can try to find JavaScript deobfuscator. And you can usually find things that'll work. So if we, let's say, put this in here. And you'll see that it kind of does the job, but not really. This one just straight doesn't. Oh, there it is. You'll see that it kind of does the job. It cleans things up, but it's not quite there. So we'll take this output for example. Another thing I like to usually use is beautifier.io. But in this case, it didn't actually clean things up correctly for me. Like as you can see, it adds all this white spaces. I don't know why. So I think I would prefer the output here. So let's take this one. Oop, that's not what I meant. Okay, so the way I usually go about figuring out what's going on here is I usually take the less scary looking parts. For example, like I can tell from here it doesn't really do any code execution besides some of these with function brackets, which we'll get to later. But for now, I'm not even sure if this works actually. This looks a bit too Also, why is Kofi coming up again? I'm gonna have to fix that after stream. Anyways, so on second thought, I actually don't think this will work. I mean, you could try. So the way I usually test this is, like I said, I'll copy the inconspicuous parts of the code that doesn't look like it's gonna do any code execution, and just paste it into the Node.js prompt. Okay, so now we should be able to see what various variables have been, what these variables are. So we could do this by hand. It's gonna be a bit slow, but this is like the easiest way to go about it, or at least the most reliable way to go about it. So you can do things like this, do things like this. This is gonna take a little bit of manual labor. I don't know if there's a better way to do this. So if anyone knows if there's a better way to do this, let me know. But this is how I usually do it. I just let the VIA engine do its thing and evaluate the code for me. Okay, so now if we type HS, yeah, okay, so you can see that evaluated this into hostname bracket. So that actually got hostname, PL platform, HD home directory, TD temp directory, and TP Windows NT type, as in like the platform type. We can also take a look at a few functions that I defined. So for example, there's an R that takes a string, basically 400 code string, and then it does its thing and then decodes it. So as you can see, we can now just do this path. RQ is probably request, yep. So here we can actually see that it's already done actually a little bit of code execution here. It requires child process. And then it calls this function, which is exec. Okay, no, there isn't any command execution yet, but when we see ex later, it's going to be used for exec. And now there's also L, which already looks like it already has some strings in it, so we can just do L. And as we can see, that it actually resolves to the C2. So we can actually just do this and replace all of that. Now we don't have to do this for everything. We only care about the ones that are actually encoded and called. Oh, actually, what I'm doing, I can, yeah, these have already been evaluated, so I can just type the names. Yeah, okay. It's URL. Oh, by the way, if you go to the repository right now, it's been pulled. I'm not sure if Bitbucket got to it first or the actor did, but it's down now. I'll probably upload the samples layer elsewhere, probably through Bazaar or something. We'll just run through all the instances of N for now. So that's local extension settings. And as you can see, that it's actually going to start doing some funky stuff like going through browsers. So as you can see, we're already seeing LDB. LDB is the extension format that's usually used for level DB. So browser-related things, extension-related things. Okay, here we can see that it's looping through things. And since we're in a controlled environment, we can also just run this. And so, for example, we can set a breakpoint here. Node.js. Cannot find module request. Right, so we're gonna have to install that. Yeah, there we go. Oh, request, sorry. Actually, I'm not sure. I think I have to navigate to the directory first. So, cd npm install. Actually, I'm not sure if tailwind.config. I don't think tailwind will be executed just yet. So I think we're fine. Okay, we only care about request at the moment. Okay, node, calm down, hang on. Node npm install request. Okay, we'll let that do its thing. Oh, node. I'll have to execute all of that here again. Solana ID, as you can see, it's trying to find the Solana related stuff. Solana is the crypto, which is also another good indication for Lazarus, because they've been known to do a lot of crypto heists. Are we good? We're good. Okay, so if we look at the, if we step in here, you'll see that it's trying to go into Chrome local extension settings. And how do we know it's trying to walk into Chrome? So if we go to I mean, like, aside from it saying there, but if we go to T, where's T defined? Right, so it actually got called from here. Actually, revalidate like this one. Edge. Ah, right, I remember. So, if we set breakpoint here, you can see that the global for J is that, and it's gonna take the input and step inside. You can see that the $ has been evaluated here as user Chrome user data, and the reason is if we do this now. Oop. So hello, white bear. Okay, so I might remember that we did a platform checker. We populated the variable for PL earlier, which is platform. So D is going to be D is going to be for Darwin, L is for Linux, and if it's neither of these, then it's Windows. And what it's doing now is we can take a look at T and C. A is the home directory. Yep. So it's going to the home directory, and we're gonna take a look at Z. That is the Mac specific user profile data. And that's config, which is on Linux. And that's app data. And we can take a look at T. If we look at what T is supposed to be, you can see that it's actually Chrome in various forms. So one is for the path for macOS, so that'll actually be like this. We can actually just remove this entire part. Oh, hello, thank you for follow. Hang on. Mag. I'm just gonna call you Iceberg. Hello. Okay. Wait, that's 2, isn't it? No, that's, yeah. Okay, it's this. Oh wait, we can't really do this because T is actually passed as a variable here. So what we can do actually is we can actually do a log. It's still console.log in. Yeah, okay, this. So we can do console.log. Backtick. Right, $. Yeah, sorry, I forgot. So you can see that it's going over to that. I think we might have messed it up. Hang on. So I'm gonna go back. It's not temporal of any of this. We can just place a debug statement there. Yeah, you can see that it's going to there, and then it's gonna go inside here. And as you can see, it's gonna try to navigate inside here. You can see that we are trying to access U. What is U? Okay, it's probably not N. Oh, you have to do U plus B. Okay, so you... Oh, we can just take a look at L. Yeah, there it is. Oh wait, sorry, I keep forgetting. Sorry, I don't do JavaScript very often. Yeah, if we place these debug statements, we can see that it's trying to walk through all of these and see if these directories exist. I think P is exists. Access sync, yeah. So it's going to try to access that. If it doesn't exist, then we'll go on to the next thing. And let's say if it does exist, let's do this. Let's do new item force. Oh, I'm pretty sure it has to be a directory actually. Item type directory. Now you might be wondering, oh, what is this extension for? We'll just let it run through the entire thing. No specific breakpoint here. Okay, so we can see that it's trying to access all these different directory paths. And as you can see, it actually didn't loop over 200 times because you have multiple profiles in Chromium-based browsers. So it's using a very dumb method to walk through all the profiles, where it just loops through 200 times and try to access 200 profiles. Because most users are probably not going to have over 200 profiles. Yeah, it's a very dumb way to do it, but it works. We can actually just copy all of this. Or not. Hang on. It's just me or it's not copying the entire thing. Hang on. Yeah, there we go. And then we can just do this. Yeah, okay, so these are all the extensions that it's trying to access. If we look these up, okay, you can see that this one is crypto.com wallet extension. This is Coin98 wallet. Phantom, also another NFT what was it called? Whatever, just call it DeFi. Yeah, decentralized finance, I think. Yeah, we can see all of these are basically crypto-related extension names. And this one actually exists on... Yeah, this one is actually specifically for Edge. There's a mask. Okay, so you can already see that it's trying to access all the different folders and see if any crypto things exist. Look at $sign. $sign is true because why? I think it's gonna check if it exists, yeah. And I guess it does. And it's gonna try to find Solana ID, which contains the crypto user stuff, I believe. I never used Solana, so someone else has to correct me. Thought they were pass managers. Small relief. I mean, I could probably try to get AI to do it. Yeah, you know what? That's a good idea. I actually wonder if it'll be able to... I spelled it wrong. That's how they get you. And as for the passer manager stuff, don't worry, we'll get to it. You're not out of the blue yet. I mean, out of the woods. Can you look at this obfuscated JS? Yeah. Okay, so it actually does. It actually is smart enough to decode some of this stuff. That is not true. Okay, here's the problem with LLM. The thing is, they're good at predicting text, based on the given input. Keep in mind, we're on 4.0 mini. The thing is, it'll usually look at this, and it actually doesn't do any of the calculations. So, if it actually did, it would be actually transferred to platform. You are simply using it wrong? Yeah, perhaps. We can probably do this, like, you know, snippet by snippet. But my point is, when you have the debugger available, I think it's more accurate to just use the debugger. That's what I'm saying. The prompt was wrong and use Model Gemini. Yeah, you can do this on your own though. That's not the point of today's stream. What is S again? Right. Oh wait, it's literally right below it. Oops. Right. So if it finds the file, then it's gonna upload it to the remote endpoint, which is gonna be that. Oh, S. Where we stream. A. So if we set a breakpoint here, what is E? L is post. Right, yeah, it's gonna try to send the data over to the C2 via the uploads endpoint. And yeah, here where you're getting to H, let's set a breakpoint there. Okay, no, that's not what I meant. Because a breakpoint here. Okay. Wait. When does H get triggered? Here. Oh, H is only for Darwin only. Okay. Also, I think I might have screwed this part up. Because, No, okay. That makes sense. So H, as you can see, it's gonna try to grab the, if I remember correctly, I think it's... and the login data. Restream. deployment. Yeah, it's gonna grab the keychain file on your Mac. It's also gonna take the keychain DB, and it's gonna yoink it and then upload it. And it's gonna try to find the directory for it. So we know H is for exfiltrating the macOS keychain file. And then it's also going to try to take and Z and X. Right. I think this, yeah, if I remember correctly, this is the Brave Wallet ID, Brave Wallet stuff. Okay, here it's trying to take the, this is definitely Firefox. So, the way the exfiltration works for Firefox is usually they just yoink the entire key DB, and they can derive the DS key from the DB. And they can work from there. Yeah, that's Firefox, see? I believe that's required for logins such as JSON. The way Firefox handles its secrets are very not secure compared to Chrome. That's not to say I like Chrome, I hate Chrome. But I prefer Chrome's approach, even though it's not particularly safe, and at least until recently. I guess while we're here, we can have a tiny little lecture on how password managers in browsers and cookies and whatnot are stored and retrieved. So for Chrome and Chromium-based browsers, what they do is they use something called DPAPI, or is a Windows-provided cryptographic interface. And the way it works is whenever you want to store a secret, you call crypt protect. You call crypt protect, I believe, or crypt protect data. Let me check. Yeah, crypt protect data. So the way it works is you call the crypt protect data with the binary you want to store, and what's going to do internally, it's going to go through it's going to use a bunch of machine keys that are on your machines. That normally cannot be exfiltrated without privilege. And it's going to use those machine keys, and then it's going to encrypt the data with it. So since this machine key is not particularly easy to steal, since it's stored under first of all, it's stored under a file. It's also stored, you also need the relevant machine GUID for it, and I think it's machine GUID. You're gonna need both of those, one in registry, one in file, and both of those require administrative privilege to access. So the way info stealers tend to work is that they would just call crypt and protect data locally before exfiltrating the browser data, since they can't just yoink the entire encrypted data over there and expect it to work when they take it back. So this isn't exactly secure, obviously. Like, you can just call crypt and protect data, and Windows will happily decrypt it for you. With recent update to Chrome, I don't know when it's gonna start rolling out. I think it's Chrome 127. They're gonna have the crypto decryption stuff handled by an elevated service. So in theory, unprivileged malware can't do that. Can't just reach in and then grab it. Now let's talk about how the way Firefox's work. The way Firefox's work is we go into login. If we go to keys4.db, I don't have SQLite browser, I believe. I don't. But if you open this in SQLite browser, you'll see a bunch of key blobs in there. And the way it works is it derives a DS key from the keys DB. And then it uses that to encrypt and decrypt stuff. So all the attacker needs to do is just yoink the DB, and they can decrypt everything. Neither is particularly secure, or at least the Chrome one is not until recently. But like Firefox is like the weakest one, unfortunately. Okay, let's move on. Bro, I am not smart enough to understand this. It's alright. You can just think of this as rambling. Like, you can probably still learn from this as well. Login data, etc. Okay, so you can see that it's trying to steal a bunch of login data. So that includes the various browser password managers, browser password managers, and the keychain files. Now, if that's all it did, then it wouldn't be very interesting. Okay, so you can see it's more Firefox stuff. Yeah, there's also key 3db. Do you mind creating a short or something from that fragment? It's too long for a clip. Okay, I'll do that after the stream. Thank you, though. I really need clippers. Or I really need to get working on some clips. But yeah, this is not very interesting because the actual interesting part is down here. So, if we come down to this RT, it'll check if this is Windows, and if it is Windows, we'll do D is not defined. Okay, well, we'll set a breakpoint here. So let it run. Okay. Step over, and then we can check T. You can see that it's trying to create a path for Python, and it's under this directory PYP. Okay, why is that? Let's take a look at what's trying to do now. So A is, I believe that's the file system one. Yeah. So it's trying to do A exists if this file exists. If it doesn't, I assume we don't have it. Because I don't think I've actually run until this part yet. Yeah, we don't have it. So, if it doesn't exist, oh, right, it's because it's run inside a promise. Hang on. Right, okay, so, in here. Right? Hello? What is it doing? Hello? Where are you in the call stack right now? Okay, it's not pausing. Okay, well, let's pretend we're in here, since we can just, you know, most of this stuff already declared outside of the outside of the scope. You can do L. You can see that that's a C2. M. O. So that's the C2. You get and Z. Write file. MPL. Okay, that's definitely not correct. So we know t is that. Assignment to a constant variable, right? God, I really hate the idea of immutable variables in JavaScript. Okay, so it's fine. We can just do this ourselves. Nope, that's not what I meant. Trying to go for H. What is H? Right, H is that. Home, that's home directory. E is something. What is E? RS MPL, right. And D is not defined. Yeah. Okay. Right, so that's that. And it's going to try to run that. So we can already see that it's trying to do something with Python, and it's trying to execute this MPL file. We come down here, a P, that's remove. It's going to try to remove, and that's get. It's going to try to get that. And as we established, this is this. So it's going to try to get this XYZ2. If the Python file doesn't exist, or rather the Python executable doesn't exist, then we'll go to AT. AT is p2.zip. Let's create a p.zi. Don't worry, that is not a typo. It's p2.zip. No, I remember what it's doing now. Yeah. So because it doesn't have the Python runtime, it's gonna try to download it. Okay, so rename sync. And what you might be wondering, what's K? I think K is the no, K is, what is K? I don't think K is defined here yet. Nope, K is that. Oh, that's a file size. Right. So it actually hard codes the file size. If it isn't the expected file size, then it just returns. Rename sync. It's gonna check if $ signs exists. So it's gonna check if the p.zi exists. And if it doesn't, it's gonna do this. Take a look at what's T. T is that. As you can see, what it's doing is it's trying to download this thing and then try to save it as p.zi with curl. And since most people, it's probably expecting you to be on Windows 10, since this would not work on Windows 10 or below, before Windows 10, because curl doesn't exist unless you happen to also have curl installed in your path, yeah. Otherwise, Crows came bundled, I think, starting 1809 build of Windows 10. Then it's gonna try to download it, and before we get to that, see that's trying to do ex, which is exec. It's trying to execute that, which I don't believe this is still up. Right? Yeah, it's not up. It's down. That's okay, because you know what? We have the file. I already grabbed it. So this is p2.zi, and I believe after this, it's gonna try to go in here, and it's gonna try to do... What's this? It's gonna use tar... Why is it using... It's using tar. It's also expecting you to have tar, I guess. What's the program? Just getting on. It's a... it's an operation from Lazarus. And this is actually a relatively old operation, which is apparently still going on. This was first reported back in, like... Actually, not that early. It's only a few months ago. But yeah, there was one that we caught for a few days ago. Or rather, Malhunter team caught. Anyways, back to what we're saying. So what it's going to do is it's going to take the p2.zip and it's going to extract it under your home directory as the PYP we just talked about. And the way it works is so funny, is that instead of installing the entire Python runtime via like installer or anything, it just downloads the entire Python runtime and installs it in your home directory, and it's gonna call it from there. They don't care if you had Python or not, they're just gonna install Python for you anyways. So I'm not gonna go on much further because we're gonna talk about the next payload, which is the XYZ2 is gonna be saved as .mpl file, which I have here. We're gonna save this. Okay. So let's focus our attention on this MPL thing, which is gonna execute in the background. So as you can see, it is basic64 encoded. All they did is they actually did an XOR with the first 8 characters, which is going to result in what's going to execute. So the way I usually do this is, again, I just bring up Python runtime. So pi-3, we can just plop this in here, copy res. We can do with open space mpl.py decoded write as f.write res. So it's expecting to be run in the same Python file. So what you should do is you should just copy paste this here instead of having it in another file, because this thing is important. S-type is going to be referenced later. So before it does any of that, it also helpfully installs requests for you in case you don't have requests installed. Which for, I assume it just didn't bundle it or something in the Python runtime. I don't know why they didn't just include the same zip. But anyways, so as you can see, it's gonna try to do this, and it's gonna try to access these host variables, which we can just see host2 is that. So just that. and it's gonna try to get directory for .n2. It's gonna try to get a directory for it, and it's gonna download the next stage payload with requests. Surely they could have done this without request, right? Surely there's something built in the Python standard library now. Anyways, so it's gonna try to download this from that /payload/s type, which is this. So in theory, this should be XYZ2. So it's gonna try to download this. And it's gonna try to save it as AP. AP is pay. So it's gonna try to save the So it's gonna try to create a directory called n2. Why cannot? You must type a file name. Yeah, okay. This window is not new enough to understand what the hell's going on. So we can just cd new item type directory n2. No, n2. Here. So it's gonna come in here. It's gonna try to download the file as pay, which we already have here as well. So it's not gonna have any extension. It's just called pay. It's gonna download it, and it's gonna try to use sys.executable, which is the current Python runtime executable, and it's gonna try to run it with this file. So it's gonna run this thing in the background, and if it thinks it's on macOS, which is Darwin, then it's just gonna exit here. But if not, we're gonna continue to the next one, which is from Bo. So same thing, but it's downloading from this /bro. Once again, we already have it here. So this is what it should look like on the victim computer. And same thing as before, it's doing this. Once again, we could just plop this in the Python runtime. Expect it to work. Yep. What do we open again? Pay. So you can see that it actually has two payloads in here. One is shorter, one is longer. So we'll split this into two parters. Nope. Unterminated string literal. Always amazes me to see where written in Python and not something low. Trust me, Python. This is actually a lot more harder to detect than their usual stuff. Why is it? Oh, it's like okay. So, ahoy, hello, welcome. Oh, hello. I didn't notice the raid. Why didn't the Oh, why did the overlay not go off? Hello. Sorry, I didn't notice until now. Hello. But yeah, it's refusing to enter that. That's fine. We can just plop that in here. We can just do this. Hello. Welcome for thank you for the raid. I hope you had a good stream. This pay.py-2 right byte. No, not right byte, just right. That's f.right, res, run this. Oh, you don't have the, okay, fine. Just do this. Copy as path. Right, I forgot to import base64. Oops. Okay. Where'd it go? Here? Yeah, here it is. Okay, so now we have two pars. We have this. We have this. So as a reminder, both of these should be in the same PY file, PAY file. We'll talk about why they're using Python and Node after this, after we're done with today's session. Just a little spoiler, I kind of already done an analysis like a few months ago. Like this is like, they just didn't change much from this operation. Well, that happened a few days ago. So the first thing they're gonna do is they're gonna try to collect system info. So that includes it's gonna go from here, here. See, contact server. It's gonna go here. We're also gonna need the S-type back because it needs it. We're also gonna need to install the Python extension. I think it's Pylance. What are you deobfuscating? So, all right, let's explain this for the raiders. All right, let's start from the top. All right, so Malware Hunter team tweeted this a few days ago. Actually, by a few days ago, I mean like 2 days or a day. They noticed that there's a Bitbucket hosting strange stuff, and I looked at it and I immediately knew this is Lazarus because the same operation occurred like a few months ago, where we'll talk about attribution at the end of the stream because it's a bit complicated. But basically, for now, all you need to know is that there is a open source repository that was hosting malicious code. And at first glance, it might look very inconspicuous. Like, it looks fine. It's like, hey, social book, right? You enjoy private chat messages. So the way they usually deploy this is you would usually go on various job hunting websites or recruitment websites. They're going to try to find people that are looking for jobs, and they're going to send them various things. AnyDesk is normally out there. Ignore that. But yeah, they're going to try to like send you interview questions and code, and they're expecting you to run it locally to test it. Like, I don't know what exactly their interview is going to be like, but they'll usually send the repository as part of it. So the way it usually works is that it is hosted on a public Git repository, so it doesn't look, it doesn't look too suspicious. And since most people assume that anything open source is not necessarily malicious, or at least they think it's usually not malicious, and they'll expect you to run it, and you'll take a look at the code. You might be one of those more careful types. You might look at the code and look, yeah, it looks fine. I don't see anything too suspicious here. It all looks fine. It checks out. So the way it works is it's actually hidden in Tailwind config, which is going to be called when you're packaging this, I believe. It's going to end up using Tailwind. And at first glance, you might think this looks normal. There's nothing too special here, right? But if you enable word wrapping, you'll see that, hey, there is a obfuscated JavaScript, like, behind the first line. And, like, you usually not see it, especially when you're using the public Git repository on Bitbucket or GitHub, etc., etc. Word wrapping. So this is word wrapping. This feature exists in most IDE, where it wraps around whenever like when it exceeds the screen width, it's gonna go into the next line. So the way it works is that it just calls this and it does its thing. And for the first half of the stream, we were talking about how this JS works. And yeah, they don't expect you to like, especially when you're viewing on a website, you're usually not gonna like bother scrolling all the way back here. Since GitHub, and I don't know if Gitbucket has a word wrapping feature in their online IDE, but on GitHub you have to specifically go onto the top right and then go onto the drop down menu and click word wrap. And that is very clever, and it's not the first time they use it. So always be careful with what you're trying to run on from various sources. Anyways, let's get back to, I guess we can briefly go over JS as well for the newcomers here. So, in the earlier part of the stream, we looked at what the JavaScript does. It expects it to be run in Node, since the tailwind and whatnot, you gotta do npm install and eventually npm run, etc., etc. Any reason they use Bitbucket over GitLab or GitHub? Not really. They actually do all of them. I don't know. I think they've used GitLab once or twice. I haven't seen it, but I know they definitely use GitHub as well. But like Bitbucket, GitHub, they're all the same. They usually get pulled down really quickly as soon as someone reports it. So if you go to the repository now, it's actually pulled. It's no longer there. But I have two of them screenshotted here. As you can see, they're both on there. You can also do... can also take a look at the git log. See that it's this Mike person. And these are usually throwaways. You usually can't really get anything from it. But it's funny that it's from... You can see that the time zone is +10. If we take a look at what time zones are in +10... Actually, not that incriminating. Not exactly easy to tell where that might be from. I guess that's just their VM's environment then. Can we still download the repo from somewhere? Usually not. I wouldn't recommend uploading the entire repo. Like, I have it, but if I actually upload the entire repo, I'm pretty sure my account will get terminated. We've already seen accounts out there that were like rehosting these, and yeah, they get pulled real quick. But after all of this, I'll upload all the relevant samples onto like just the JS itself and the relevant Python and JS payloads. I'll upload them to Bazaar. I'll post them on my Twitter after this. Okay, back to what we're saying. So this JS that is being run under let's see, this is what it would normally look like once you've beautified it. You'll see that it is not particularly readable, but like if you try hard enough, it's actually not that difficult. So you can see already replaced some of the strings here, but the way it works is it runs the JavaScript, and it's going to go through a bunch of things. So first of all, it's going to take your crypto wallet. It's going to go through your local extension settings for all of your Chromium-based browsers, and it's going to scan for various extension IDs. Do I still have it open? I don't. Well, just know that it's going to go through like things like Coinbase, wallet.com, etc., etc. It's going to try to take the LDBN log files from there, which basically copies the entire extension over. It's going to upload it to their C2 via their /upload endpoint. And it's also going to take your... If you're on Mac OS, it's going to take your keychain file. And if you have Firefox, it's also going to take your logins.json and keys.db and various other things. I really gotta shut Kofi up. It can like, I don't know, time you out for a little bit. Thank you. I'll figure out what's wrong with Kofi after this. Usually doesn't do that. Anyways, yeah, it's gonna take the various wallet related stuff. So for example, it also mentions Solana up there somewhere. And so there's also Brave wallet as well. It's also gonna check for Brave. And it's gonna check for Firefox, etc, etc. Okay, I think you get the point. After that, after it's exfiltrated all the data it needs, it's gonna download a few things. First of all, it's gonna get the Python runtime. It's gonna download the entire Python runtime for you. In this case, we have it here as p2.zip. It's gonna download it via curl, which it assumes you have curl already. Which for any Windows 10, 18, 09 above versions should have curl. Yeah, it's gonna download that and then plop it into your user directory under the .pyp folder. After that, it's gonna download this XYZ2. This is usually the campaign name. In this case, just gibberish, XYZ2. They just mashed their keyboard, I guess. It's going to save it as the MPL file under your home directory. And then after that, it's going to use Python for the next stage. And it's going to do MPL, do this. Normally, it's not like this. Normally, it's supposed to look like this, where it's going to execute and it's going to decode using XOR, using the first 8 characters, and then do the rest, decode it, and then execute it. Hello, Chris, hello. Okay. So after that, after we decode all that, it's gonna install requests. It's gonna go to the C2. It's gonna download. It's gonna download from there. It's gonna create a new directory called .n2, like here, and it's gonna download the payload and then execute it and save it. It's gonna save it as pay and then execute it via the same Python runtime. And if it's on macOS, it's gonna execute. It's gonna exit from here, and if not, it's gonna continue running and then download the BOW. Now, here we are looking at we're looking at pay. So, I have the Python runtime installed. I should be able to just do this now. Okay, so as you can see, it's using the same IP and port. It's going to collect all the data. Step over. You can see what C looks like by going to debug console. You can see that it's trying to take TS as in the current timestamp. Type is the campaign ID. HID is the current computer name. SS is the command type. And CC is the command parameter. And if we look at c.cc, CCC, you can see that it has generated a UUID, which is just a unique ID that it generates from. Where does it generate that from? It calls a get ID. Oh, it uses the I think get node is the. What is get node? Good question. What is get node? Get node. Where is it imported from? UUID. Gets the hardware address as a 40 8-bit positive integers. Oh, okay, so MAC address. Okay. So you're gonna take that and get the current user, and it's gonna do a SHA-256 on it to get the hash. So it is still a unique identifier. And if we look at what CC is, you can see that it's collected various things like the system version, system, hostname, username. It includes your net info. Don't worry, this is not my actual location. But you can see that it also collects things. It collects all of this data from IP API, which is a thing you can just call to see what your current IP looks like. So it's going to collect all of that, and it's going to post it over to D. And D is that. It's going to post it to keys. How are you from Taiwan? I don't know. I just live here. I'll take that as a compliment, I guess. Is that American? Nah, not really. I really am Taiwanese. So, we established that the first part of the payload is just gonna collect stuff and then execute it. And it's gonna collect system information. Now, next up, let's take a look at what's going on here. Okay, I believe this is the actual rat component of it. We'll come back to this later. Put a pin on it. Let's take a look at the bowl first. A lot of cultures learn from American English. Honestly, I kind of just learned that from interacting with people online. Like, including the accent and whatnot. Which, I guess, are Americans online? I don't know. I already have it decoded here. I'm not going to go through all that again. So, the reason why I'm going to take a look at this first is because this one is relatively easier to look at. So, once again, it's doing a lot of silly things. It's gonna install the packages, including PY Win32, request Pi Cryptodome, secret storage. All of these are legitimate libraries that it's gonna use later. And this entire bowl.py basically boils down to it's a browser stealer. So for the Chrome one, it just excuse me, it just takes the Chrome data. It's gonna go through 120 profiles, and I'm gonna loop through all of them. Does it do the decryption anywhere? So I can actually talk about the decryption again. Like, aside from the decrypt Windows password. Yeah, yes. Okay, so let's go over the basics again for browser stealers. The way it works, at least up until Chrome 127, is that all of your data is actually stored, if you're using Chrome and Chromium-based browsers, all of your data is actually stored under the user data profile directory. And depending on how many profiles you have, you might have a lot of different profiles if you have like multiple users. And all of that is stored inside there. And it's going to store an encryption key as part of... I forgot exactly where it's stored. Hang on. Yeah, it's stored under this safe storage thing. And the way it works is it takes the key. The key is normally stored under the file, and the file is actually encrypted using DP-API, a Windows API for decrypting and encrypting safe storage or any sensitive data. And the way DP-API works is that it uses a bunch of machine keys that are on your system. So with two crucial components, one of them is under a file, one of them is under a user profile app data, and the other is stored in registry. Both of these files require system privileges to access. So the way DP API works is that it does all that for you without needing to elevate. So whenever Chrome wants to encrypt something, it just calls crypt protect data to safeguard the things it need, along with the additional key it might want. And since we know how it works, we can just revert all of that, walk back to it, and call crypt unprotect data. Now, up until Chrome 127, this was relatively unsafe because anyone can just call crypt unprotect data, since it's just a Windows API. And of course, it is better than no protection. Like if there were no protection, the attacker can just yoink the entire Chrome profile folder, and they'll be able to do anything. But with DP API, it has to with any stealers before it exfiltrates any data, it'll have to call crypt and protect data locally because it needs the machine keys that are on your system. If it yoinked the entire profile data and then copy it to your system, it's not going to work because there's no encryption key. And when you take that from there, and when you take all of that, and if you call crypt unprotect data first, then you can take the unencrypted buffer and then yoink it elsewhere, and then they're going to upload somewhere else. So that's how it works for all the Chromium-based browsers. So that includes all these. I believe Yandex uses something a little bit more different, so I'm not even sure if this works. Yandex uses their own secret storage, I think. But yeah, it's gonna check for Chrome, Opera, Brave, Yandex, MSH. We can talk a little bit about how you can protect yourself against this. But first, let me talk about the recent changes to Chrome. Now, personally, is it even 127? I forgot. Let me double check. Okay, it is. $127. Yeah, it's 127. Okay. So at least for Chrome, I don't know if this is gonna get backported to Chromium. At least for Chrome, and starting from Chrome 127, it's gonna have an elevated service that handles the decryption process. So malware can't just call crypt encrypt data because it needs a key required. The actual key, parts of the key that is required, it used to be stored in a file. Now it is stored in memory inside this elevated service, and malware now has to elevate itself in order to read the parts of a key, and that's not particularly easy already. You have to elevate, and then you have to do memory scanning to try to figure out where the thing is, where the key is. So in theory, this makes it a lot more difficult, but this is still not, like, even in this post, acknowledged it is not bulletproof, because once the info stealer actually elevates, it can still do it can still figure out a way to do all of that. And getting elevation in an enterprise environment is not as easy if done properly. So this was more specifically focused on enterprise environments. Since if you are a regular user on Chrome, what you'd probably do if you're like most people who hate UAC, you might just turn it off. By the way, don't do that. That is very bad. Do not disable UAC. In fact, I would recommend put it on the high. Because if you turn UAC off, basically anything, if it requests elevation, it's just gonna elevate. Like, there's no protection. You can find out more of what I'm talking about in the book for Windows Internals, edition 7. I think it was like chapter 6 or 7 or something, where they talk about how UAC works. And the gist of it is that if you want to ensure nothing elevates outside of your, if you want to make sure that everything that needs to elevate goes through you, then yeah, do that. Of course, this is not gonna necessarily, since UAC is not necessarily a quote-unquote security boundary, you can with other exploits they can still elevate usually, and occasionally you might also find things that claim to quote-unquote bypass UAC, but the way they usually work is that you'll still have to prompt a UAC window or two, just as a Windows process. So at the very least, if you have UAC enabled to the top, to the maximum level, then you should still at least be quote-unquote safe. At least, you know, safe as in like, as you don't just like click yes on every UAC window that pops up. If they have remote access to victim and mouse and keyboard, can they bypass UAC? Once again, they have to elevate somehow. Them having remote access doesn't necessarily mean they can elevate. The way you can, in Windows, you can really lock down how privilege escalation works by, for example, disabling SE debug privilege, or limited to admins only, and enabling UAC to highest. That way, unless they have other local privilege escalation exploits they can use, otherwise they can't really elevate based on just you having mouse and keyboard alone. Anyway, so my point is, Chrome should, in theory, be a little bit more secure in this area now, but it's still not bulletproof, because back to the whole UAC thing, most normal user, quote unquote, they usually disable UAC because they find it very annoying, even though that annoyance is actually meant for something. Don't do that, by the way. Usually when they have it disabled, that means anything can just elevate. So, yeah. This at least helps in an enterprise environment where admin privileges are locked down. For example, if you're in an AD join the domain, a normal user probably only has normal user privilege, etc., etc. Okay, back to what we're saying. This should at least work before Chrome 127. I don't know if anyone's figured out a way around the aforementioned security service yet. I assume someone has. I just never looked into it because I don't use Chrome. Which, speaking of, let's talk about how bad Firefox handles it. I use Firefox, and the way Firefox works is really stupid. Oh, it is actually not handled in here. Okay, well, you're safe against, you're safe if you're using Firefox then, or at least for this one. In the earlier payload, we did have to, the attacker did go through the logins.json file and keysdb. So let me re-explain how the Firefox security password encryption works. So the way Firefox encryption works is the data is actually stored, the encryption key is actually stored in something called keys.db. This might be key3.db, key4.db. The number is just for like the versioning, I believe. And if you have the DB, then you can derive the DES passphrase from this DB. And then from there, you can decrypt anything for Firefox. And this file is not protected in any way. It is not like locked to admin privileges. It is not locked behind anything secure. You can just copy this, paste this anywhere else. And if the attacker gets hold of this, then goodbye your data. So yeah, the way it works on Firefox is a lot, quote-unquote, less secure. Like, I kind of wish they have a better security model for it, but it is the way it is. I believe eventually this all of this gets exfiltrated. It's gonna send it. Oh yeah, it only saves it to a file. It doesn't actually send it anywhere. Okay, I guess while we're here, let's talk about how you can protect yourself against this. one really hardcore way you can prevent this, or not prevent this, but like helps in some way, is you can use inferior. How do you pronounce that? Hang on. Let me grab the relevant edge policy tab. Always wonder why Firefox is still counted in such high regards. I mean, Firefox is good in certain cases. Like, it is relatively behind in certain APIs where they're straight up not available. But first of all, at least it's not, you know, Google. A second thing is, you know, they're still standing behind Manifest v2, whereas Chrome is like deprecating Manifest v2 very soon. That means you can't use uBlock Origin. Or at least, there is uBlock Lite, which is way inferior because like it can only handle like very few amount of elements. That's due to the restriction of Manifest v3. Anyways, I'm not here to start browser war. You can like whatever you like. I personally just use Firefox though. Anyways, policy definitions, paste in here. So one hardcore way you can go about defending yourself is you can enable, where is it? Is it enable? You can just do search profile. I can never figure out how you're supposed to pronounce this word. Hang on. Hello, I want pronunciation. No, not pronounce. Oh, I forgot. Oops. Ephemeral. Yeah, that's it. You can enable profiles so that every time you exit the browser, everything is wiped. That includes your login information, that includes your extension. All of your extensions will be gone, by the way. This is like very hardcore way to do it. I usually recommend it for when you're using a throwaway browser, where like you're not doing anything important there. You don't have a bunch of extensions installed. That is one way to do it, but it's not bulletproof since the profile is actually still stored until you close the browser. The other way you can do it is by installing a few additional add-ons like cookie auto delete, where like every time you close a tab, the cookie gets deleted, etc., etc. And also don't use the built-in browser password manager, because those are protected by the same mechanism I talked about earlier, where it's just one crypt unprotected away and they can see your thing. That's for Chrome. Cookie auto delete. Let me show that real quick. Yeah, this is a good extension to have, but you'll also you might also get a lot more annoyed eventually because all of your cookies delete as soon as you leave the website. So there's that. That way you are at least somewhat not as prone to like session hijacking. But like if you still have the tab open at all times, then it doesn't really matter. Also, I think you can enable delete browser data on exit. Is that a thing in here? I know that's a thing on Firefox and in Edge. Well, I'm sure there's a setting somewhere you can use, but yeah, there should be a setting where you can like delete everything on browser exit. That includes history, cookies, etc., etc. That also means you have to adjust your browsing habit a little bit, where you don't have like a bunch of tabs open, which is preferable anyways. You probably shouldn't have a bunch of tabs open. Okay. Let's talk about the next part of payload, which is pay, the second part of pay.py, or just pay. So, this thing is actually a fully featured rat written in Python. So, where do we start? Let's set a breakpoint. Show client. Okay, it's gonna call client. Do this. Okay, so it's on port 5001. I believe it's using the same IP as well. It's gonna try to create a TCP connection. Gonna call a session. Gonna do connect. We're just gonna do a socket connection. Yep, it's all socket based. So it'll try to connect. I don't think the C2 is up. I think it's dead. Like the entire C2 is dead. We can talk about how and what this thing does. So the way it works is it monitors your clipboard events, as you can see from down here. It can collect the clipboard data whenever. It is stored in memory, I believe. Yeah, it's written to ebuff, and the ebuff is not cleared and retrieved until the attacker wants to. So the main thing, the main rat component is actually inside this shell class. So it supports 8 different commands. And let's go through each of them, I guess. So first of all, SSH object. So even though it's called SSH, it's not really SSH. It's just what they're calling their remote shell thing. I don't believe this comment was here before in other versions. I guess they didn't bother to remove the comments. That's funny. Anyway, so yeah, it basically calls it's the SSH object is basically a remote shell, where it just calls the shell and then have the pipe. And here also there's a decode string. Oh, that's just the code page stuff. Anyway, so anything that gets thrown in here will be from the CMD. The attacker helpfully left their what the response is supposed to look like. So it'll take the CMD in the JSON and execute that. Is it waiting or calling? So the way it works is that it is constantly waiting for the next instruction. So as you can see, it's constantly waiting, doing session receive. And if there's something, then it'll do the thing. If not, it'll just continue looping. And yeah, so that's number one. That is a exec command. Now, if we look at SSH CMD, send all. Oh, that's just part of the yeah, okay. So that's part of the same command. It's just the post handling, where it does the sending part. So SSH clip. So SSH clip, it's gonna send the buffer from the clipboard and then reset the buffer. So this is just send clipboard data. SSH run. That's gonna run the browser stealer. JavaScript, I mean Python. exec browser stealer Python script ssh upload. Right, this is a basic file management command. So ssupa, yeah, it's gonna upload, or depending on what you do. So sdra is gonna upload the entire directory, I believe. Yeah, it's gonna walk the directory and then upload it. sdir, I think that just gets the... Wait, no, this is upload directory. What is the other one? They look the same to me. They both look like they're uploading directory. Okay, I'm not sure what the extra A is for. S-file, I believe that also uploads just the file itself. Yep. Let's find A, this is for finding file. You find, yeah, it's gonna walk the directory and then try to find a matching file. Okay, so we can see that the SSH upload is actually a file management, or rather, file download upload. Wait, is there upload? I don't think so. I just file to download, yeah. SSH kill, that's gonna kill browsers. Very specific. Right, SSH any, so this one is kind of funny. So it's gonna try to download a... Hang on a second, let me drink. It's gonna download any desk and then execute it, which we'll get to in a little bit. It's gonna download a Python script from /adc. And then ssh env. Oh, right, I remember. Now, yeah. So it's... FM... No, not... FM... If I remember correctly, SSLD is gonna look through the files and it's gonna upload them. So I believe it's these files that it's looking for at envs. Yeah. So it's gonna try to collect all of these sensitive data. So that may include documents, anything that includes password, account, private, wallet, MetaMask, secret, config.js, any .envs. What is this ex file for? Right, it's gonna exclude those files. STAR. It seems to skip those as well. Yeah, it seems like it's only interested in the sensitive documents. Oh yeah, whenever it uploads the files, it actually stores them. This is what we call locally staging data. So, store binary. Where is it? Where is T? Oh, right. So it's also gonna. So the way it works is that it's gonna try to store the data from via FTP. I don't think the FTP server is still up. I think it's down already. But it's gonna locally stage data and then upload it via FTP if I remember correctly. It's also gonna use that as a key. Okay, so that basically sums up all of the things that you can do. Command execution, clipboard monitoring, browser stealing, download files, kill browsers, collect sensitive data, and download AnyDesk. Now, the way the AnyDesk thing works is actually kind of funny. The entire operation is kind of funny in retrospect, actually. But, does it do self-replicating, hiding, restoring stuff? Not entirely sure what you mean. By the way, I just want to check if the FTP is still up. Hang on. I hide in registry? No, it doesn't do any of that. Because it wants to do all of that without any privilege escalation. To access registry, you're gonna need. Well, okay, that's not entirely true, but like in most cases, to access registry, you're gonna need admin privileges. Module not found. Okay, you know what? It's fine. QI win 32. So it's already. Gonna take the args. Where's args? Oh, right. Now I remember. Yeah, it doesn't really give you the credentials. It's like it's not hard coded in here. Yeah, it's like it has to be given from the attacker. Right. That makes sense. Okay, so there's that. Now we can move on to the adc.py, which is once again wrapped in this thing. We'll do file write as f.write res. I probably shouldn't have. Oh, now it's executed. Great. adc.py. Coded. There we go. Okay. So the way this language Python, the way this AnyDesk thing works is actually, I don't know if that's funny or not. Okay, so the way it works is that it downloads the AnyDesk file from. Where is it? Yeah, it just downloads it from /any. And it's going to save it as anydesk.exe, and it's going to try to save it under the home directory. And after that, before it actually starts AnyDesk, it'll actually try to create a PowerShell file, and it's gonna try to populate the credentials inside the config files. Also, what happened to the music? You might think, oh, well, great. Does the credential work? No, it doesn't. I don't know why it did never work for me. Like, I'll let it run, and it'll run AnyDesk, and it'll populate the credentials, but it never seems to log in. I don't know why. But anyway, so it's gonna use this PowerShell file to append the password, etc., and there into the service.conf file. I'm not entirely sure why they didn't just do this in Python. I don't know why they're relying on PowerShell, because that means more logging. This is definitely gonna get caught by ETW. But yeah, eventually it's gonna run that. It's gonna run AnyDesk. Then it's gonna try to run AnyDesk again. I'm not entirely sure why, because like in theory it's already done all of this above. I don't know, it has to reload or something. But yeah, it's gonna run AnyDesk, restart it, and if it works, you should be logged into the victims, or rather the attacker's control, the attacker controlled AnyDesk account. But yeah, it never worked for me. So, let's move on to what this thing is for. And let's also talk about attribution. This, I believe this has been reported on several times, but the this Chinese one is the most comprehensive. I'll just give you like a rough translation of it. So what they're saying is basically they'll go on various recruit websites, so such as LinkedIn, Upwork, Brain Trust, and then they're gonna pretend to be someone looking for hire, and such as that they're pretending to be like a indie startup or something like that, and they'll tell you, hey, they're looking for software developers, and they're gonna give you the repository, and you're gonna download it, and you're gonna run it, and then you're gonna accidentally trigger it. Wait, didn't Mandiant do this? Hang on, Beavertail. That sounds like a Mandiant naming scheme. It's not? Oh, is it? Oh, it's Palo Alto. Okay, I think this actually might be a little more comprehensive. So this has been observed since last November. It's basically the same as what that particular thing talked about, where they're gonna run the code and it's gonna download the thing, and it's gonna run the JavaScript, and it's gonna run the Python. And they are typically crypto related, and as you can see, some people have uploaded some of the conversation histories. As you can see, that a lot of people actually report this, and there are actually quite a few GitHub repositories related to this attack. There are also some on GitLab as well, and some on Bitbucket. And it's the same thing as before, where it adds a bunch of white space and then the actual malicious JavaScript. And as you can see, the TTP is the same. Also obfuscated again. I don't know if they're using any specific obfuscator, honestly, but like, it's very typical of JavaScript obfuscation, where it's just like everything is hidden behind a function, or like everything's base64 and already coded, etc., etc. Here you can see that it's trying to access the wallet extensions, and it's more or less what we've seen so far. So the reason why people are attributing this to Lazarus is because this relates to their ongoing campaign that has been going on since probably like 2009 or something, and it's dubbed Operation Dream Job, where they typically disguise themselves as a job recruiter and then try to spread their malware from these recruiting operations. This is fairly common for them to do, and first of all, the reason why this operation is attributed to Lazarus is because, one, this is very similar to their Operation Dream Job, and second, they are interested in crypto. Lazarus has been a group that has been heavily focused on crypto for a long while now. You probably heard of quite a few Web3 operations that got disrupted by them, Web3 like companies. And just to be clear, if you're not familiar with North Korean groups, Lazarus is not the only North Korean groups. Not every North Korean groups are Lazarus. A lot of people outside seems to think that, but I believe I think CISA or FBI or CIA, one of them, published a documentation on how the insides of North Korean operation works. And Lazarus is just one of the group. The other ones including people like Kim Suki and I think Dario. There are like at least 4 subgroups in the North Korean groups, as far as I remember from that report. Anyway, so that is the attribution. This operation has been going on since March 2023. So the files we're examining now is actually quite recent. Like I mentioned, if you take a look at the Git log, you can see that it's actually committed just a day ago. So fairly new, and the repo's down already, if you're wondering. So yeah, now as for why they're using Python and JavaScript, it's actually really relatively difficult to detect, mainly because they're running on the engine themselves that these things run in are basically JIT, and it's really hard to do bytecode pattern matching of these engines. Yeah, sure, you can detect the JS and the Python files themselves, that's another thing. But under most, let's say if you don't have the detection rules, static detection rules on these files, you're most likely going to miss them. And since most things that are JS and Python tend to be things that, I wouldn't say legitimate, but like, they're not usually as, let's just say, scanned as deeply as something like a C or C++ written binary, which Lazarus from a few years ago actually relied heavily on C and C++ based malwares. In fact, that's probably been the thing since like 2009. So it wasn't until like recent years that they started to branch out to different territories using different languages. You might think that code is written shoddily, sure, but it gets the job done. And you might think the code is shit, I can write better. That doesn't really matter, because whether or not the code quality is good, it doesn't matter, because it gets whatever they want to do done. Now that's not to say they're not still writing C and C++ malware. They still do that. You probably still find a bunch of reports on NukeSped, like their proprietary downloader, a lot. So Lazarus has plenty of operations that are like ongoing. Like, they probably have different subgroups that do different things. I assume that this LinkedIn kind of stuff is handled by one subgroup, and the usual NukeSped stuff is handled by another group, etc., etc. where like they have different people for different operations. But in this case, we can see that they are particularly interested in crypto and stealing sensitive data, and this is how they do it. The thing with this operation is that if you back out a little bit and take a look at this whole thing as a whole, like, you might think, wow, this seems very rudimentary. How is anyone gonna fall for this? People always just fall for this because they take advantage of various human psychology and how we think, and they are relatively experienced in this kind of stuff, where they know how to trick a victim into doing something. So that includes, for example, the code execution here, where they're pretending to be a recruiter, they're putting things in the JS files, hoping you don't notice, because most people legitimately aren't going to notice. Because when you receive a code repository, when you stumble upon something on GitHub, are you really going to go through each and every file and figure out what each of them do before you run it? The chances are you're only going to look at a few files and think, yeah, that looks fine. Because like, if you look at the rest of the stuff, all of this looks normal. Because they are normal. There's nothing wrong with them. They're probably stolen off somewhere. And, you know, of course, you're going to miss a file or two. And in this case, it's this file. And that's how they get you. So, yeah. This is not the first time people have done this. Where they're putting things in an open source repository and hoping you don't notice. For example, if you are trying to, let's say, compile, let's say you might think, oh, if I received an exe, I might find this suspicious. I want to compile this myself. What they can do is, for example, if it's anything Microsoft Visual C++ related, they can just put they can put malicious code inside, for example, post-compile events, where like the thing gets triggered whenever the compiler finishes or before it starts. There are a lot of ways you can get around things like this, so you just really gotta be careful with what you do and how you approach these files, especially if they're from a company you haven't heard of. I guess that would be my recommendations on how to prevent against this type of attack. Alternatively, just don't have LinkedIn. I don't have LinkedIn, but I know a lot of people use it. I don't really understand why. Because I don't know. I don't know if people use LinkedIn a lot or not, but it seems like I see a lot of people use it. But even without LinkedIn, there have been other operations from Lazarus where they reach out via other means. So, for example, in one of their operations before, they tried to trick a security researcher into executing malicious code. I think Mandian did a write-up on it. Let's see. The Google tag team. Lazarus security researcher. Yeah, this one. Yeah, so even let's say if you don't have LinkedIn, they might reach out to you through other means. So in this case, they have a fake account that pretends to be someone who works at a company or a developer or someone. Even it's actually fairly, like, the profile itself actually looks fairly convincing. They even have like PGP key, very convincing profile, etc., etc. But yeah. Does it not say? Tag has. At least one popular. Okay, this is not the one I'm looking for. Oh yeah, these are more like it. So with a lot of these, they'll usually pretend to send you like a CV or something for if you're interested. And yeah, as well as talking about, you can put stuff inside a pre-built event, inside a visual or act. I'm not sure if it's just Visual C++, but like any solution files that can do this. There are a lot of them. You can, yeah, these are fairly common as well as part of their operations. So always be very careful with who you interact with. I guess it's not just LinkedIn. And with any new contact that you come in contact with, be very careful. Even if they seem legit, I will usually, if it's on X, I'll usually check if they are followed by any other known malware researchers in the community. And if not, I'll probably, yeah, just be very careful. You have any juicy worm to analyze? See, the thing is, with APT malwares, they're usually not as sophisticated as you think, or at least the ones that are sophisticated enough are usually under detection. You probably don't even know this. But for your average APT operations, they tend to be like relatively shoddily written. I would argue cyber criminal groups tend to write better malware than these APT groups. That's not to say all of them though, because some of the APT groups are really good at what they do. For example, APT 41, China-based APT group, they tend to have quite a few good stuff. But usually the really sophisticated stuff is like beyond my scope of knowledge. Also, there's the problem with whether or not I can share it. Once again, the reason why today's stream is possible is because it was from a public GitHub repository, Bitbucket repository. I obviously cannot talk about anything I do at work on stream. There's my policy. Not just my policy, my company also wants me to abide by those policies, where like I can't talk about anything that's like not white. Yeah. So that's also one of the reasons why these streams are relatively rare. I like to do more, but it's just a problem of finding good ones to talk about, and ones that I can actually talk about. That is. I guess that's it. I thought about making all of this into a video. That's what I was gonna do like a few weeks ago with the script writing stream before I got struck by a freaking branch. Which, by the way, I still don't think I'm completely recovered. Anyways, I don't know. I'll figure something out. Like, I really want to make these into a video, but it's just a hassle of editing and script writing that makes me not want to do it. Because I genuinely do think these are interesting stuff to talk about, especially for people that aren't into threat intelligence. Because these are things that people might actually run into. Who likes editing video? I mean, I know a lot of video editors that actually do enjoy working on their stuff. Anyways, before I sign off, once again, our new music video is up. Go watch it. The Rise Up cover. Oh my god, my voice. Yeah, go watch that. I'll put that in the chat. And as for people on YouTube, just go click on the channel link. And I guess that's it. Any questions before I go? Let me see if I can rate anyone. Okay. Who can we raid? Oh, Jolly is doing Voices of the Void. Oh, you know what? Let's raid Jolly. Sure, why not? We have 15 viewers. Wow, that's a lot more than usual. Okay, yeah, I'll see you guys later. Bye-bye.